Now we're going to solve for the variable in some logarithmic equations. There are two types of logarithmic equations. The type we have here is if you have log equals log is what I'll call them. If you have the same type of log on both sides of the equation, then that means the arguments must be equal. So in part A, we have a log base 3 equals a log base 3, which means that the arguments, 3x minus 4, must equal 2x plus 1. Solving for x, bring the 2x to the left and the 4 to the right, we get x to be 5. We do need to check our answers here. You have to make sure that when you plug in your answer, your argument is still positive. 3 times 5 minus 4, positive. 2 times 5 plus 1, positive. So 5 is our answer. In part B, you need to have only one log on both sides of the equation. Since we are adding logarithms, we will multiply their arguments. 3x plus 4 times x makes 3x squared plus 4x. So notice I still have the natural log sticking around. Now we have natural log equals natural log. So if you have the same log on both sides, then you can just set the arguments to be equal. This gives us a quadratic equation. We can solve this by factoring if it's possible, or the quadratic formula, which will always work. I think this one does factor, so I'll subtract the 15 from both sides. And let me play with this because, I don't have the answer in front of me. I wish I did, though. I think it's like 3x plus 5x minus 3. Let me check that. Nope, it's 3x minus 5. 3x minus 5x plus 3, right? Because that makes 9x and minus 5. All right, good. So this says x is positive 5/3 and x is negative 3. But check it. 5/3 is okay. Boop. But if I put a negative 3, it makes both of the arguments negative. So we can't accept it. But just as a comment, all it takes is for one argument to be negative. So if you had 99 logs and 98 of them were fine, but one of them were negative or 0, you would say, no, it's not a solution. So our only solution is x equaling 5/3.